Good afternoon, students. Today we are going to learn about 555 Astable multivibrator using 555 timer IC. Basically, Astable multivibrator we can construct using 555 timer IC also, as well as using the op-amp, as well as using the transistor. So in the earlier semester we had already studied this Astable multivibrator using the transistor. So now in this semester we'll use 555 timer IC for this Astable multivibrator. Now basically Astable multivibrator, it is a free running multivibrator because we are not applying any kind of external input signal. So without applying any external input signal, it will gives you the continuous square wave as an output side. So this continuous square wave, so the name is given as a free running multivibrator. Then second thing, we do not require any kind of trigger input signal for this. Without external signal and without any trigger input, this generates a square wave output. So we'll receive the square wave output. Now here in this circuit, the circuit is very simple. 555 timer IC, it is a 8-pin IC. Here we can simply short 8 and 4. Then we can connect one more resistor in between pin number 8 and 7. Then in between pin number 7 and 6. Then since we are not using trigger input, we need to short to pin number 6. So here pin number 6 and 2, these are shorted together, and then one more capacitor 1 microfarad is connected between pin number 6 and ground. So you can connect either between pin number 6 and ground or between pin number 2 and ground. Both are correct. Then at the pin number 1 and 5 we need to connect disc capacitor, 0.01 microfarad disc capacitor. That is for the noise elimination. We can short, we can connect here capacitor, and one more wire we need to take in ground separately. Then at the pin number 3 we need to connect one DSO, one channel probe we can connect here to observe the output. Now here we can observe the output by two methods. First, if I want to observe on DSO, I can observe on DSO. Otherwise, if I don't have DSO any issues, then I can check with the combination of one small resistor value with the LED combination. So if LED continuously glows, it turns on and off, so it indicates your square wave output. Continuously on and off, so it indicates your square wave output. So in terms of that also I can observe this 555 Astable multivibrator output. Now here I'll show you the how can we connect on the breadboard. So this is my timer IC. First you need to identify pin sequence. After that pin sequence, connect the circuit. These two red wires, these are for I connected here. 1 and 5 shorted here. This is 8 and 4 shorted. Then after 1 and 5 short, this yellow color wire, this is again connected to ground. Then these two resistors, the values are mentioned in the circuit diagram. These are connected like this: 8 and 7, 7 and 6. This is a electrolytic capacitor. Need to identify positive and negative. Positive is connected to pin number 2 and other side negative is connected to ground. Then here I had connected this DSO 1 channel is used to observe the output. So positive is connected here to pin number 3 and negative is as usual connected to ground. And for this operation I used plus 5 volt power supply here. It is given to this 555 timer IC. Now if you look at the DSO screen, you can clearly observe the square wave output on the screen.
So this frequency of this output depends upon what?
Here you can find this duty cycle for this square wave. T on time period is this one, and T off time period is this one. So you can able to calculate the duty cycle for this.
So if I need to change the frequency, what change do I need to make in this circuit?
For the frequency, here we need to change the resistor values here, and this capacitor, we can observe the capacitor charging, discharging waveforms also. So we need to change these values over here, and if you change simply here with the help of this knob also, you can able to change this one, and you can calculate the duty cycle. You need to observe symmetrical and asymmetrical duty cycle in this case. So if both the time periods are equal, obviously the duty cycle will be the symmetrical. T on equals to T off 50%. So symmetrical duty cycle,
So
like that.
which resistor is responsible for T on and which resistor is responsible for T off?
There is a specific formula we need to solve on the formulas. So just now we had only the setup for to check the output first. For the charging time and discharging time, the specific formulas are there. For the
What are those
frequency also.
formulas? Now in this circuit diagram, would you just tell me which resistor is responsible for T on and which resistor is responsible for T off? What is the charging path and discharging path of the capacitor?
For the this charging, it will this capacitor it will charge towards this, and discharging path is via this and inside the internal structure of 555 transistor and flip flop combination and comparator is there. So when it will discharge, so for the discharge it will take the path of this RB into C. For formulas we can observe that TD is equal to RB into C and TC is equal to RA plus RB into C. So that formula is there, and for the frequency 1.45 divided by RA plus RB into C, such a formula is there. So right now we had not done any calculation, we had just only checked the output. We'll do that calculation.